Hello friends, welcome to our channel. I hope you are all in a very good health and studying well with your full focus. Thank you for joining me. Today we are going to discuss about right circular cylinder. This is our this is the second part of this chapter. So let us take some questions and try to solve them. So this is our first question which says a right circular cylindrical tank of 5 meter height is filled with water. Water comes out from there through a pipe of diameter 8 centimeter at a speed of 225 meter per minute, and the tank becomes empty after 45 minutes. Find the diameter of the tank. So let us draw it. Let the radius of the tank be r and its height is 5 meter. It is given, the height is given, which is 5 meter. It is filled with water. Water comes out from there through a pipe of diameter 8 centimeter. So there is a pipe in it. Water comes out through this pipe whose diameter is 8 centimeter. That means the radius of it is 4 centimeter, and the speed of water is 225 meter per minute. In 1 minute, the length of water column which is formed in this pipe is 225 meter. That means in 1 minute, the length of the water column is, let us assume, in 1 minute, this is the length of water column. Okay. In 1 minute, water can go this far. So the length is 225 meter. Okay. We are assuming that in 1 minute the water column formed inside this pipe has a length of 225 meter. So now the tank becomes empty after 45 minutes. Therefore, we can say, let us assume that this water column, that means the water column formed in 1 minute, The length of that water column is 225 meter and the radius is 4 centimeter. So the volume of this water column, okay, let us write it small v. Okay, the volume of water inside this pipe. Okay, and this water column has formed in 1 minute time. So the volume of this water column should be, now let us write it by small v. The volume of it is, we know, pi into r square. R is 4 into h. So we have to keep the units same. So instead of writing 4 centimeter, we are writing 4 by 100 meter. So we have converted this into meter. So 4, so pi r square into h. H is 225 meter. So this is the volume of water in 1 minute. Okay, this is the volume of water in 1 minute. Therefore, in 45 minutes, the volume of water column formed should be equal to 45 into this quantity. That means 22 by 7 into if we cancel it by 4, we are getting 1 by 25. So we can write 25 square, that means 1 by 625 into 225. So this is the volume. So we can write it in meter cube. And after 45 minutes, the tank is empty. That means the volume of water inside the tank, if we consider it capital V, which is equal to pi into capital R square into H meter cube. So when this volume of water is completely drained through the pipe, then the tank becomes empty. So this volume should be equal to this volume. Okay, now we can equate these two quantities. So we can write, therefore 22 by 7 into capital R square, which we do not know, into 5 equal to 45 into 22 by 7 into 1 by 625 into 225. So this is what we are getting. Now if we cancel pi from both sides of the equation, we are left with this. Now we can cancel 45 by 5. So this is 9. So r square is equal to 9 into 225 by 625. So r should be equal to 3 into 15 by 25. So if we cancel this by 5, we are getting 9 by 5. So this is our radius. Therefore diameter of the cylinder is equal to 2 into 9 by 5 meter. So we can write it 18 by 5 meter. So it is equal to 3.6 meter. Okay, so this is our answer, diameter of the cylinder. This is our answer. So I hope the question is clear to you. This kind of question actually comes in exams. Now our second question says the length, breadth and height of a parallelepiped made by copper are 11 centimeter, 9 centimeter and 6 centimeter respectively. Let us write by calculating the number of coins having the length of diameter 3 centimeter and 1/4 centimeter thickness will be obtained by melting the parallelepiped. I hope the question is clear to you. Let us see the diagram. This is our parallelepiped made of copper. Length, breadth and height are given. We are melting it to make some coins. Let us assume that the number of coins be n. So n times one coin, where the dimension of the coin is the dimensions of the coin are the radius is 3 by 2, as it is said in the question that the diameter should be equal to 3 centimeter. That means the radius is 3 by 2 and the thickness of the coin should be 1 by 4. So when we are melting something to make something else, we are actually working with the volume. So the volume of the copper parallelepiped should be volume of the parallelepiped Vp. Okay, let us write it. We know the volume of a parallelepiped is length into breadth into height. That is 11 into 9 into 6 centimeter cube, and volume of one coin is equal to, we are denoting it by Vc, the volume of coins. We have n number of coins and the volume of one coin is pi r square, that means 9 by 4 into h, that is 1/4 centimeter cube. So this volume should be equal to this volume if no copper is wasted. So this volume should be equal to this volume. Now let us equate it. So this is our equation. Now let us solve it. So we can cancel 22 by 11. So this is 2. We can cancel 9 from both sides. We can cancel 6 by 2, which is equal to 3. So n is equal to 3 into 3 into 4 into 4 into 7. This is the value of n. That means n should be equal to 16 into 21. So 16 into 21. So 336 coins can be made using that parallelepiped. I hope this question is clear to you. Now, friends, let us proceed to our next question. So, this is our third question, which says if a gas cylinder for fuel purpose having the length of 7.5 decimeter and inner diameter of 2.8 decimeter carries 15.015 kg of gas, find the weight of the gas per decimeter cube. So let us first draw it. So we are going to consider only the inner radius. So inner diameter is 2.8 decimeter. So the inner radius Ri should be equal to 1.4 dcm. Here only inner dimensions are considered because the gas is filled inside the cylinder. Okay, the gas occupies the volume of the hollow cylinder. So we are going to consider only the inner cylinder. So the radius inner should be 1.4 and the length is given, which is equal to 7.5 dcm. Now it says that it carries 15.015 kg of gas. Now we are going to find the weight of the gas per decimeter cube. That means the volume of the density of the gas. Now let us first write the mass of the gas, 15.015 kg, and the volume is equal to 22 by 7 into 1.4 square into um, 7.5 dcm cube. Therefore, weight of the gas per decimeter cube, which is equal to density. So the density is equal to mass by volume. So the mass is 15.015 kg by 22 by 7 into 1.4 into 1.4 into 7.5 dcm cube. So if we calculate it, we are getting 0.325 kg per dcm cube. So this should be our answer. Our next question is question number 6, which says out of three jars of equal diameter and height, diameter and height are same. 2/3 part of the first, 5/6 part of the second, and 7/9 part of the third were filled with dilute sulfuric acid. Whole of acid in 3 jars were poured into a jar of 2.1 decimeter diameter. As a result, the height of the acid in that jar becomes 4.1 decimeter. If the length of the diameter of each type of 3 equal jars is 1.4 centimeter, let us write by calculating the heights of the 3 jars. So let us first draw it to understand it better. So these are our 3 equal jars. There is no need to draw it 3 times. We can simply multiply it by 3. Um, it has same diameter and height. So the radius of each jar is r and the height, let us assume it is h. Okay, and they are saying that if the length of the diameter of 3 equal jars is 1.4, so 1.4 and so the radius is 0.7. So the radius is 0.7 dcm and the height we do not know. So the volume of acid in first jar V1, it is two-third part of the first, two-third. So two-third into pi into 0.7 into 0.7 into h dcm cube. Volume of acid in second jar, which is 5/6 part. And V3 is equal to 7/9 part. So these are 3 volumes. Now we are pouring. Now we are transferring this acid into a bigger jar. Okay, we are transferring this acid into a bigger jar, which has the dimension 2.1 decimeter diameter. 2.1 decimeter. So the radius should be equal to 2.1 by 2 dcm, and the height after transferring the acid becomes 4.1 decimeter. So let us write the volume of the bigger jar, which is equal to V. So pi into 1.05 whole square into 4.1 dcm cube. All these volumes are in dcm cube. So this combined volume should be equal to this volume. So we can write, therefore V1 plus V2 plus V3 should be equal to capital V. Or we can write pi into 0.7 into 0.7 into H within bracket 2/3 plus 5/6 plus 7/9. This volume is equal to pi into 1.05 into 1.05 into 4.1. So this is our equation. Now we can cancel pi. We can write it 7 by 10, 7 by 10, 105 by 100, 105 by 100, 4.1 by 100. Sorry, 4.1 by 10. So 20 and 100 can be cancelled. And by 7 we can cancel 105. It becomes 15. And by 7 again we can cancel 105. It becomes 15. So we are left with H within bracket. Let us add these fractions. So the LCM should be 9. The LCM should be 18. So 12, 15, 14 equal to 225 into 41 by 1000. Now 41 by 18 equal to 225 into 41 by 1000. So we can cancel 41 from both sides. So H is equal to 18 into 225 by 1000. So we are getting 4.05 decimeter. That's all, friends, for today. I hope you have understood it. Thank you, friends.